Welcome back to my channel. Okay guys, basically today we will be dealing with implicit differentiation. As you can see here, we are going to find the dy over dx by implicit differentiation of these functions. However, in order for us to be able to find the dy over dx by implicit of these functions, we must know the definition of implicit differentiation. Technically, the technique of implicit differentiation allows us to find the derivative of y with respect to the variable x without having to solve the given equation for y. Okay guys, I will show you exactly what I'm talking about when I say for implicit differentiation, you don't have to solve this expression for y, meaning that if we were given x plus y equal to 9, and we are asked to find dy over dx by implicit differentiation, we are not going to start by solving this equation so that we make y subject of the formula. Okay, and one thing we should recall is that differentiation itself, it takes this form: y equal to x to the power n. Here we are asked to find dy over dx. Okay guys, to find dy over dx of this function, it's very simple. We will just do it like this: dy over dx equal to derivate x to the power n, we will bring n to the front, and again we're going to subtract minus 1. We will subtract 1 from that exponent n. Okay guys, for instance, let's say we have y minus 2x equal to 0, and we are asked to find dy over dx. But this time around, we are not told anything about implicit differentiation, meaning that we will just do it like this. We will first solve or we will make y subject of the formula. Then if we do that, we will get y equal to 2x. Okay, from here we're gonna do it like this. We will do it like this. We're gonna simply say d over dx times y equal to this. On this one, guys, we will just isolate 2, since 2 is a constant and we are interested in x. Then we will say 2 d over dx times x. Then this one is nothing but dy over dx equal to 2, since dx over dx is 1. Okay guys, let's solve these equations by implicit differentiation. To solve this one by implicit differentiation, we're gonna do it like this: d over dx of x plus y equal to 9. Equal to 9. Then let's go ahead and find the derivative of this one. Then it will give us dx over dx plus dy over dx equal to d9 over dx Okay, guys, dx over dx will give us 1 plus dy over dx will just give us dy over dx. Dy over dx equal to d9 over dx. Okay guys, the derivative of a constant is 0 because 9 is a constant, meaning that this one, if we derivate 9, will give us 0. let's go ahead and solve for dy over dx. If we solve for dy over dx, we're gonna get dy over dx equal to, here we have positive 1. If we bring this positive 1 to the right hand side, then we will have negative 1. Yeah, then we are done with number 1. Let's go ahead and solve number 2. Number 2, on number 2 we have, to solve number 2, we're gonna do it like this, guys. D over dx of x squared plus y squared equal to, yeah, I think it was equal to 0. Okay, equal to 0. Then let's go ahead and solve this one. To solve this one, guys, we're gonna do it like this. The derivative of x squared will just give us 2x plus the derivative of y squared will just give us 2y times dy over dx. Okay, guys, the reason why the derivative of x squared gave us dy over dx is just that y and x are two different variables. Okay, here we just have 2y because dx over dx, they will cancel, meaning that they will give us 1. Then we will be left with 2x. Then, but on this one, we will have 2y dy over dx, since we are derivating another variable with respect to another variable. Then we will just get the derivative of 0 is a constant, then the derivative of 0 will give us 0. Okay, guys, let's go ahead and find the dy over dx. But here we can do it in this way. You can take out the highest common factor of 2, or you can simply do it like this. 2y dy over dx equal to dy over dx equal to, here we have positive 2x. Then if we bring that to the right hand side, then we will have negative 2x. Okay, guys, in this step we're gonna do it like this. We have 2y dy over dx, but we are looking for dy over dx. To get rid of 2y, we will do it like this. We will just divide throughout by negative, by 2y. Then if we do that, we will just get dy over dx equal to negative x divided by y. Yeah, that's the answer, guys. Okay, let's go ahead and solve number 3. Then number 3, I think on number 3 we'll have On number 3 we have y. On number 3, you guys, we have x, xy. It's xy equal to 1. Yeah, we have it like this. Okay, to derivate this one, we will just do it like this. Number 3, ne? Number 3, d over dx of this function, d over dx of this function, d over dx of this function Okay guys, here we have x, y, meaning that whenever you have two variables that are multiplying each other, you will just do it like this. You will first derivate the first variable and then keeping the second one constant, plus, because here we will just use what we call product rule. Okay, let me just do it quickly. Then by doing that, guys, we will derivate x, and then the derivative of x is 1, and keeping y constant times y, plus, then this time around we will keep the variable x constant, x times the derivative of y, but the derivative of y is nothing but dy over dx equal to the derivative of 1. 1 is a constant, guys, then the derivative of 1 will give us 0. Okay, let's go ahead and solve for dy over dx. Then if we do that, we will just get dy over, okay, let me do it step by step. We will just get x times dy over dx equal to negative, because here we have y, we have 1y, but y1 is nothing but 1. Then here we will have negative y. Let's go ahead and solve for dy over dx. Then dy over dx will give us dy over dx will give us negative y divided by x, negative y divided by x. Yeah, then that's it, guys, for this video. Thank you for watching, and please, guys, subscribe to my channel so that I can bring more content